All right, so first question we'll take a look at. This is solving a linear equation. So generally, you don't have to do any factoring. You don't have to do quadratic formula. You're just trying to get x by itself. All right, so what would be our first step if we want to get x by itself? Yeah,
Subtract 6 on both sides.
Yeah, so subtract 6 on both sides. What does that leave me with on the left side?
2/3.
Yep, that'll leave me with 2/3 x. 2/3 x. And on the right side, 12 minus 6. Was it? Yeah, okay, that's all right. 6. Okay, so now we got to deal with the fraction in front of the variable. So what are we going to do on both sides to get rid of the 2/3? Yeah.
Divide by 2.
Yeah, you can divide each side by 2/3, which is the same as multiplying each side by 3/2. Yep. So we'll multiply by 3/2. By 3/2. When you multiply 3/2 times 2/3, you get 1. So that cancels out. And we get what for a final answer for x?
9.
9. Yep, x equals 9. So that's solving a linear equation, pretty basic, not a lot of steps. Any questions on that one? Okay. All right, so the next question we'll look at, this is going to be solving a quadratic. In order to solve a quadratic equation, we always want to get it equal to something first. Well, what do we want to get it equal to? Cool.
0.
Yeah, we want to get it equal to 0. And I usually like to make sure the x squared term is positive. It's not a huge deal, but let's see if we can do it that way. So let's move everything that's on the left side onto the right side to the left side. So if we do that, what would be on the left side if that's where we put everything?
3x squared minus 2x minus 6.
Yep, so you'd minus the 2x, you'd minus the 6. And now we've got it equal to 0. So if we're going to use quadratic formula, well, you got to remember what the formula is. Does anyone remember, can you remind me what's the quadratic formula? Yep, Sophia.
Negative b equals minus x of b squared minus 4ac over 2a.
2a. And now make sure we know what letter is what to plug in. Okay, so what's a going to be in this case? 3. And b? -2. And c? -6. All right, so we'll fill them all in. Hopefully, if it comes out imaginary, I should have checked that. So, nope, we're going to be okay because c is negative. So, yeah, we're fine. All right, so negative b, well, that's going to be -2. Plus or minus, what's b squared?
4.
Gives me 4. Minus 4 times a is 3. Times c is -6. All over 2 times a, which is 6. All right, so now, under the square root, we're going to be subtracting a negative number. When you subtract a negative, that's going to turn into? That's going to be turned into adding. So now we have, let's see, 4 times 3 gives me 12, and then times 6.
72.
12 times 6 is 72, and then plus 4. 76. Now, if we can't reduce the square root of 76, that's as simple as it gets. We can check if 76 is divisible by a perfect square, then we need to reduce it. So if you try to divide 76 by 4, yeah, we can do that. So we have to break up the square root of 76 into the square root of 4 times 19. Because 4 times 19 gives you 76. Right, and now what's the square root of 4? 2. So you get 2 plus or minus 2 root 19 over 6. But then everything there is divisible, everything on the outside of the root is divisible by what? 2. So we can divide everything by 2. So that becomes a 1, that becomes a 1, and that becomes 3. And that's going to be our final answer. So 1 plus or minus 19 over 3. Now, if this was a quadratic equation, excuse me, about like a word problem, we'd have to see if the negative answer makes sense. If we were solving for like the length of something, the negative answer we'd get rid of it. Right? But if we're just solving a quadratic and there's no word problem to go with it, then we need to make sure we write both answers. Okay. Any questions on that one? Okay, so the next one is going to be, it's going to kind of combine two things, solving absolute value inequalities, but then it's also going to turn into solving linear inequalities once we start to do it. So if you want to solve an absolute value inequality, what's the first thing you have to make sure of? And in this problem, it's not done, so we have to do it. Yeah?
Get like the absolute value by itself.
Yeah, we got to make sure that the absolute value is by itself. So it doesn't matter what's inside the bars. It matters what's outside right now. There's something outside we don't want there. So we do not want this times 3 on the outside. So what would we do on both sides to get rid of that 3? Yeah.
Divide by 3.
Yep, and divide by 3. And then when you divide by 3, that cancels. So what do we have on the left side now?
The absolute value of x plus 2.
Yep. If we had divided by a negative 3, we'd be flipping that sign right now. Okay, but we didn't divide by a negative, so we just leave that alone. And then 12 divided by 3 gives me 4. Okay, so now we've got the absolute value by itself. What do we do now?
Split it up into like 2 equations.
Right, now to get rid of the bars, you have to split it into 2 problems. Do you remember, Jose, what one of my inequalities would be?
X plus 2 is less than or equal to 4.
Good. X plus 2 is less than or equal to 4. We need a word here. We'll talk about that in a second. And does anyone else remember what the second one is? Yeah?
X plus 2 is greater than or equal to negative 4.
Greater than or equal to negative 4. Okay. And the word that we put between them comes from, once you isolate the absolute value, you look at that symbol. That's a less than. Does anyone remember what word we use when it's less than or less than or equal to? Yep.
And.
Yep, that's an and. So we'll solve each one and see what happens. So we get x is less than or equal to 2, and x is greater than or equal to negative 6. So this second part is solving a linear inequality because it doesn't have absolute values. So that's where the second part of the problem comes in. No division here, but if you had a number in front of x, you'd have to divide by it. And if it was a negative, you'd have to flip the sign. Okay. Any questions on that one? Okay, so this one we're going to look at is solving an inequality. It's a quadratic. If it's factorable, we can try to do the sign pattern, but if it's not, we need to use the calculator. So let's graph it. If it doesn't dip below the x-axis, I'm going to have to adjust it. Okay, so let me graph it and just kind of see what this looks like. And I'm hoping that it goes under. If it doesn't, I'll try to fix it. So minus 4x minus 17. Perfect. So it does go under. It's not really necessary to see the minimum. We're not looking for that in this case. We're just looking for where it's under the x-axis. And if we want, we can even just kind of just draw in the bottom part. We know it's going to do something like that. All right, so we're looking for where this one is greater than 0, so above the x-axis. How many sections of this graph are above the x-axis?
2.
Yeah, there's really 2 separate sections. You can kind of think of this as section 1, and that is section 2. What are we going to have to do to figure out the intervals here? We're going to have to know something about that graph. Well, let's start to describe the interval and then see if we run into something that we don't know. Okay, this will be interval 1. So on interval 1, what's the lowest x value that you could pick and still be on this part of the graph that goes up?
0.
Well, if you pick 0, you're going to be right here on your graph.
Is it like the second calc x or something?
Okay, we'll come back to that in a second. For this question that I just asked, you don't need to do that yet.
Okay.
But you will. So what's the lowest x value you could pick and still be on section 1 of the graph? Yeah?
Negative infinity.
You can go to negative infinity because section 1 goes up and it goes to the left forever. So you can go all the way to negative infinity. Now, the highest x value that you can pick and still be in section 1 is right there. That's the highest x value. If you go past that, you are going to dip down into the blue section or even be in the second green section. Right? So what do we have to find to figure out what's going to go right there? Yeah.
0.
Yeah, we have to find the 0. So we'll do second calc 0. So my cursor is down at negative 17 and my x value is negative 0.45. So I'm like right by like the zoom button. So I'm going to keep pressing left and now my cursor is coming back up. So pick a point that's to the left, pick a point to the right, and do your guess. And that's not a nice number, so it probably would not have been a factorable problem. So we can go up to negative 1.81. Now, do we include or not include negative 1.81? We don't include it because it says we can't equal 0. We have to be above 0. So don't include it. And now we have another interval. What symbol do we use when we have to write a second interval?
The U.
Yep, the U. It means it's like or. So or. Now I need to know where interval 2 starts. For that, we need to do second calc 0 again. Does anybody have where interval 2 starts? Yep.
3.14.
Okay, so 3.14. And where does interval 2 stop? Like, what's the furthest right you could pick a value and still be in section 2? Yep.
Infinity.
Right, you could just keep going to the right. You're just going to be way up on your graph. And that would be the answer where it's above 0. If you want to know where it's below 0, it's between negative 1.81 and 3.14. That's the blue section. So that's solving a quadratic inequality on the calculator. Any questions on that? Okay. All right, so in this one we've got a graph, and I'm just going to ask you to identify some values. All right. So let's make like a table. It's really just identifying coordinates. When x is negative 2, what does it look like the y value would be? Yeah?
2.
Yeah, when x is negative 2, let's say you're right there. You're up at it's about, looks like it's 2. How about when x is, let's say when x is 1, what does it look like the y value would be?
Negative 2.5.
Yeah, let's say when x is 1, right about there, I'd say that's about negative 2.5. All right, let's do it the other way. How about when y is 4? When the y value is 4, what does it look like the x value would be? Yeah.
2 and 2/3.
Yeah, it's a little more. 2.5 would probably be like right about there. So 2.6 or 2.7. I would accept a little bit of a range on that. So about 2.6, 2.7. How about when y is let's say when y is 1. What's the x value when y is 1?
Like 2.25.
Let's see, 2.25. Yeah, I would say that's 1. So about, just say about 2.2. Is there any other x value? Yeah.
Negative 1.5.
Yeah, I'd say about negative 1.5. And is there anything else? You could write these all in separate lines. I'm just putting them all together because they have the same y value. Yeah.
Negative 4.
When y is 1, so we just put this line right here. You think the x value is what again?
Negative 4.
Well, I would say negative 4. You'd be more down there.
Oh, shoot.
Yeah.
It's like. I don't know.
Not sure. Anyone?
Negative 3.8.
Yeah, it's definitely more than 3.5. 3.7, negative 3.8. Anything like that. So there are multiple x values that have the same y value, and that's what a lot of people miss. You can have multiple x values. That's pretty much it for taking a graph and then identifying points. Any questions on that? All right. All right, so in this one, we're looking for an end behavior model. Okay, so remember, end behavior model is basically something there that would describe what the end behavior of that would look like. And if you zoom out far enough, this end behavior model would look identical to f of x. So anyone think they know what the EBM is here? Yeah.
Negative 3x to the 6th.
Yeah, negative 3x to the 6th. That's our end behavior model. Anyone want me to graph that and graph the original and show you that they're pretty similar? They might not look similar if you're zoomed in, but if you zoom out, they'll definitely look very similar. So that's the EBM. Now, one thing we want to be able to do is determine the end behavior itself from the model. So now, we can do it as arrows, but then I also want to do it with the limit notation. So what would be the end behavior of this one? We have a negative number in front, and we have an even exponent. Yeah, it's going to be down, down. Okay, so it is down, down. Now, I want to describe, let's do this one first, and then we'll do this one second. All right, so the first one. The limit f of x as x approaches. When you're looking at this arrow, the one in the red box, that's describing what happens as you head which way on the x-axis.
What?
As you head left. And what's the furthest left value that you can think of on the x-axis?
Negative infinity.
Negative infinity. So this one describes what happens to y as you head left. The green one is going to describe what happens to x as you head to the right. And what value do you approach as you go further and further to the right? Positive infinity. You really leave a lot of space, but we don't need a lot of space. Okay, let's start with the red one. As you head further and further and further to the left, what is the y value going to get close to? Not which way is it going. I know which way it's going. But what is it going to? That's the question. It's going to negative infinity. And then, as you head further and further to the right, what is the y value getting close to? It's also going to negative infinity. It's going down on both sides. So that's how you find an end behavior model and describe the end behavior both in limit notation and with the arrows. Yeah.
How would this be like shown on the test?
I could give you something pretty much exactly like that f of x, and then say to determine the end behavior or describe the end behavior. And I could say describe the end behavior using arrows or describe the end behavior using limit notation. Either way. The limit notation is a little bit more formal. Yeah. Any other questions on that? Now, how about if I gave you something like this? 4x cubed plus ax squared minus bx plus 6. And I said to you to find the end behavior. Now, the one up above, you could just graph it. Negative 3x to the 6th and look at it. Can you graph this one? Why not? Yeah, it is variables for coefficients. You don't know what the graph is, so you can't type this in on a calculator. So you have to be able to figure out the end behavior without a calculator. What here is going to tell you what the end behavior is?
Isn't it just the highest exponent?
A little bit more than just the exponent. Yep.
The leading factor, I don't know, it's something like that. Leading term?
The term, yes. So it's that leading term. So it's the number that's the coefficient along with the exponent. So in this case, it's a positive 4 and an odd exponent. Yeah, what's that going to be?
I was going to ask if you could draw the chart that tells you.
The chart? Yeah, I'll just bring it up from the notes.
Okay, I have
Yeah.
it. Oh, is it 8?
Anyone think they know which way this one's going to go? Yeah?
Down in the notch.
Yeah, I just think of it as x cubed. The 4 is, whether it's a 4, a 5, a 6, or a 1, it doesn't matter. X cubed looks like this. So I know it's down on the left and up on the right. Does anybody want to see the chart in the video?
Yeah.
Okay. All right, so this one now, we're going to find the local extrema of 2x cubed minus 5x plus 6. When I ask for local extrema, what is the two things I want you to find? Yep.
The local min and local max.
Yep, local min and local max. So for that, we use the calculator. There is our sketch. So we definitely have a local min and a local max. Let's start with the local max. How do we use the calculator to get the local max? Yeah.
Second calc and max.
Second calc maximum. Yep. We pick a point left, pick a point right, do our guess. Okay. Let's put that here. Now, the calculator gives you everything you need, but you do need to put the correct number. What's the local maximum? 9.04. Yes. The maximum itself is the y value. The where it occurs, that's the x value.
Can you do a question where, you know how you did like an interval, you graphed an interval? Like the thing where it was like,
Graph an interval.
yeah.
What topic does it apply to? I'm not sure.
I don't know, I just didn't know how to press the buttons to get to that.
The one we just did today.
Yeah.
To graph an interval?
Yeah.
Okay. So I'm not sure what you want me to type in.
Yeah, I'm not sure either.
Yes, using all the
Question.
buttons and what to press so that way the graph was.
Oh, like the step function we drew?
Yeah.
Oh, you don't really have to know how to draw that, but it was math, number, and then it was 5. So that's the integer function, which takes a number in and it rounds it down.
Yeah.
That's what that
I
function
understood that, I just missed the steps on how to play.
Yeah.
Okay.
Would that be a continuous or discontinuous function?
Discontinuous.
Yeah, that's discontinuous. Does anyone want me to do the local min on that one? No? Okay. So let's see. All right, so let's look at that same graph we have. And let's see if we can figure out the domain and the range. So separate question. What would be the domain of this 2x cubed minus 5x plus 6?
Isn't that
Yeah, it's all real numbers because there's no square roots and there's no fractions with a letter in the bottom. So the two things that could mess up the domain are not in polynomials ever. So every polynomial has a domain of all real numbers. How about the range? That's domain is how far left and right it goes. Range is up and down. Yeah, this says you're going to have a range of negative infinity to infinity. How come, and this ties in with end behavior, how come every odd degree polynomial will have a range of all real numbers?
I'm not sure.
All right, well, what's the end behavior of an odd degree polynomial?
Doesn't it go up?
So I need two things to describe the end behavior. I need a description on the left side and a description on the right side.
Down, up,
Okay, that's one possibility, down, up,
or up, down.
or up, down. So why is the range of an odd polynomial always going to be all real numbers?
Because it either goes up, all the way down, all the way up, or all the way up and all the way down.
Right, it goes up and down forever, no matter which way you draw it. So it's going to always have all real numbers. And it's always connected. You never lift your pencil when you draw it. So domain is all real numbers.
What if it was even?
If it's even, that's not true. Think of like a parabola, right? So if you had something like, let's say, x, I could do something more complicated than a parabola. I could do 2x to the fourth minus 3x squared minus 5. This is not going to go up and down forever. This is an even, so it's either both up or both down. In this case, it's both up. So let's say I asked you for the domain and range of that one. Well, let's start with the domain. And let me put the function there so people can see what we did. Let me go like this. Okay. What's the domain?
All the numbers.
All real numbers, because that's a polynomial. Now, does that graph go up and down forever?
Just up.
It goes up forever. Yeah, so we can at least start with that. How would I figure out the lowest that it goes?
Second calculation.
Yeah. And I mean, these look like they're both the same level, but we should check it just in case when you zoom in, if one of them, kind of looks like this, there might be one that's actually a little bit lower than the other. I don't think that's the case in this one, but we should check both. So second calc minimum. Pick a point to the left, to the right, and do your guess. So one minimum is at negative 6.125. And then second calc minimum. Go left, right, and enter. And the other one is at negative 6.125. So they are the same value. So the range here would be negative 6.125 and up. Bracket or parenthesis on negative 6.125. Right, because we do hit that value on the graph. Right. Always check both. All right, and I think that pretty much covers all the topics.